So now we're going to graph another function that's related to the sine function, sine of 2 theta. So now the difference is, instead of having the 2 outside of the sine, it's inside the sine. And you'll recall if I have a generic function and I multiply it by a like this inside, I multiply x by a, this is going to form horizontal compression or stretch. So let's take a look at the function we have here. So for instance, we know that sine of pi over 2, that's equal to 1. Okay. Now let's try to see what should be the input for our new function, 2 theta, so that the output is 1. And so that this corresponds to pi over 2 again. So what would have theta to be? Well, in this case, it would have to be pi over 4. Because 2 times pi over 4 is pi over 2. So we see that where we used to have a value of 1 at pi over 2, now it's the same value for y occurs at pi over 4. So we can start to see that there's a compression that's going to be made on our graph. So let's investigate this just to confirm our assumption. So sine of pi, that's 0. What would have theta to be so that we end up at 0 again? Well, it would have to be pi over 2. So again, you see from pi, we get this. We have to move to pi over 2 to get the same y value. Similarly, from pi over 2, we have to move to pi over 4 to get the same y value. So everything's going to get compressed. So let's take a look at the graph. So that's going to be a compression of a half. So 1 minus 1 is still the range, because sine of whatever, right? Sine of whatever is always going to be between minus 1 and 1. Previously, on the previous example, we had sine of 2 theta. Now the 2 here changes the range of the function, because sine being between minus 1 and 1, this now is between minus 2 and 2. But if I have the sine of anything, like sine of 2 theta, but sine of whatever, that's always going to be between minus 1 and 1. So at 0, we'll still at 0. But then instead of having, we used to have like a full cycle. So this, when this is pi and 2 pi, we had a full cycle of sine like this. So this is sine of theta. But now if we look at our new function, sine of 2 theta, everything is now compressed. So the value of 0 I had at pi, now it's at pi over 2. Previously I had a value of 1 at pi over 2, but now it's at pi over 4. So now our curve is going to look like this. So I've got a full cycle if I go about the interval 0 pi. So the period now is not 2 pi anymore. Period is pi now. And then it's going to repeat itself like that again and again. Kind of pretty when you see the two graphs side by side. So I encourage you to go and see in your book page 605 and take a look at figure 8. You're going to see something that looks a lot like what I just did here. So how's the period linked to the value that multiplies theta? It's pretty obvious. The period was 2 pi now before, and now it's become pi. So we divide the previous period of 2 pi by 2. So the previous so the period in general. So if I have y equals sine of, let's say, b theta, then the period is going to be 2 pi divided by What about that? 2 pi divided by absolute value of b. Absolute value because it could happen that b is negative. So I'd have something like this, for instance. Okay, and then the minus sign would be responsible for a vertical, a reflection across the y-axis. Okay, but the period would still be of 2 pi over absolute value of b in that case.